right. So we're doing spreadsheet manager work today.
Yes, and the goal of the spreadsheet is to, the goal is, no, the spreadsheet of the discussion is to discuss what we could be doing this year, basically together as a group. Okay? And in particular, if we decide so, is to decide maybe some components and technology for our protocol or stack or whatever we want to do, basically, right? Okay, here we go. So sorry, we started this idea of a spreadsheet just a few days ago. No, yesterday. Okay, and so it's pretty empty. Okay, I thought I put. Okay, so I've been good enough to lose content. Okay, I wrote much more than that. Okay, so on.
Can you share did you share edit permissions on this spreadsheet?
I think it was open to anyone who's got the link.
Okay.
So let me just try to get back the link. The link is here.
Oh, I'm excited. Picking parts.
So in the yearly commands thread on Discord, I'm trying to put. Okay, interesting.
Oh, the boards are on the wrong row. It should be in the compute row, and then the column headings should be, I guess, configs or something. I don't know. Options.
So I don't know whether you can hear me, but apparently I can't access the document. Oh, yes. I can't access the document, maybe. Okay. Okay, even is a viewer. Okay, so let me change that to editor.
Yes.
Okay. Sorry about that. So we should change. We should swap. I think I tried to. I just tried to collect from the thread. Is it upside down? Okay. So anyway, the few words that we can see in the end in this document are based on the discussion in this thread on Discord. Okay, and so the goal would be, okay, this year, what can we do together? As what can we build together? Okay, can we achieve something together? Given that we have very complementary skills. Okay, we have mechanical, electronics, software, system. 3D printing, CAD skills, components, and so on. Okay, so can't we leverage this complementarity to do something together? Okay? And if we want something exciting, perhaps using technologies that motivates us. Okay, and so it could be anything from the Raspberry Pi to Jetson Nano. To interesting wheel designs or interesting architecture of the body, okay, as we've done the first year, especially, okay, of the YakRover. It could be also basically very specific ideas. So, for example, in the past few days, we discussed about having basically wheels that have agency. Okay, I'm pretty fond of the idea. Okay. So what I mean by wheel that have agency, that is the idea that the wheel is not only the mechanical component, okay, but also the electronics that goes with it. So having, for example, an Arduino and all the software that goes with it, that goes with the motor and the actual wheel, okay, all together, okay. To do what is another question, but we've talked over the past couple of years about reasons to do so. Okay, so maybe it's at the right time to experiment with that, for example. So sorry, just a short introduction, but the starting point is what we have so far, and the idea of setting a common goal. For example, for the end of this year, so that perhaps we can have a yearly event, to present as we've done so far, we've done in the past already. Okay, so okay. So someone, maybe Venkatesh, is adding, so on the line we have different components. Okay, so for example, the compute, the motors, and so on, and the columns are different options. So which one what we could choose. Okay, and I guess part of the discussion would be maybe to see whether we can narrow down.
I think one of the discussions we were having in the Discord is this sort of like component selection matrix is downstream of the basic assumed architecture. So if you do something like modular wheels, each with an Arduino, it assumes something fundamentally different, right? So the sheet we're filling out right now is kind of like implicitly assuming standard type rover with a single computer and motors, whereas the modular plug and play intelligent wheels thing will have a slightly different tab. So I suggest for each sort of like class of design, we make a separate tab. So for example, your spider bot, I believe, has 12 servos, right? And that's a 12 servos and no drive motors, which is a different sort of corner of design space than my rover, which is 4 motors and 4 servos. So we should probably, I don't know quite how to model that here.
It also seems like the differences that lead to not being able to collaborate, the differences that are relevant may not be everything. Like, it doesn't necessarily matter for, or I don't know, maybe they'll do, like, what items actually matter that need to be a shared stack for us to make shared progress versus what things can be more flexible and provide room for experimentation. Or is it more just about making it easier for folks to not have to think about these dimensions?
Yes.
Like, to me, the biggest one is like compute. Like, if you're going to have software that tries to work on more than one rover, then being able to target a limited set of architectures is very beneficial. But everything else is kind of specific, rover specific anyway. Does that resonate?
Yes, it's a very important point because the thing that there are so many options that if there is any hope to get anything, to be proud of by the end of the year, it seems that important to make choices, basically, to reduce the number of options. And so, for example, for the software, if it's more important to be portable to many platforms, that will restrict the things we can do. But if we are pleased by a specific platform, so for example, the Jetson Nano is pretty popular apparently, that has consequences on software, on what we can do, and we may be less portable, but maybe we'll be able to achieve specific features that is exciting the group, basically.
Well, what we could do is build something common, and then people can replace at a later stage whatever they want. In the beginning, like, we could have a common shared build, and then people can swap in whatever later on.
Can I ask, is there a set of core objectives that we're moving towards the fulfillment of? Like, because like one I would ask is is part of the objective of the chosen platform or stack one that is appealing to encourage more people to join the group?
So just one aspect that I was trying to push forward at the beginning of the thread is to have something at all, okay, but common and bigger than anything we can do alone on our own, okay. And so I was taking as a baseline the first year. Okay? The first year, for example, Venkatesh progressed a lot on several mechanical aspects, but much less on the software, okay, side. While others who started with some kits, so for example, Meyer did a lot of progress on software. Okay, we had a demo at the end of the first year, but there was limited work on almost no work on the mechanical design. Some work on the electronics because there were a problem on the bus and stuff like that. Okay, but that was mainly software. Okay, and so this is not surprising. Okay, with a time budget, depending on our skills or inclinations and so on, we will work more on what we can do basically. Okay, so can we put all that together? Okay? And so it's not necessarily to me the goal is to have something that can be reused by someone else or being modular and so on. It depends on the qualities we choose, but it's more about leveraging a group work to try to do something we couldn't do on our own and learn in the process.
But this is still in the framing of like 8 years from now, shipping hardware to Mars, right?
Yeah,
I think it's a line, yes.
yeah. Even if we never get there, I think that's our true north. So, like, more focused on rovers than high-speed robots. So, yeah, I think this is still a rover project, not like arbitrary robotics.
And still operating under the kind of constraints of very limited budget, and that really cheap parts can get you really, really far.
Yep. So the thing you posted
Whether
about,
whether that's true or not, I don't know.
I mean, I think that one is like participate at whatever level you can. But that first robotics site that you linked, that stuff it looked pretty expensive. Like there were.
You'd have to have a pretty significant budget to pull off.
I wouldn't blow that much right now at my skill level.
Right.
So,
And that was much cheaper than more industrial. Like I was just doing a bunch of Googling, right? And there was a bunch of like more industrial scale, like servos and equipment for people building like the real shit. And that's probably double the budget, at least for from the first robotic stuff. The first robotic stuff is like, oh, students with a sponsorship can build a robot.
yeah, and those are teams. The students' teams
Yeah.
look like they were about 10, 15. So if a high school budget had like $20,000, that's much more than we are throwing at this.
Yeah, first is very, very expensive. Like a big portion of the activity in any first team is fundraising. Like it really is kind of a company in terms of its existence and the tasks it performs, the first teams. So they like the basic kit, I think, is still to even like get started, you need at minimum 15,000, and that excludes like travel expenses for the team to go to competitions, like the rest of the robot. That's literally just the kit of the standard components. Building the actual robot can be like $50,000, $100,000. Some of these teams spend per year. And that's excluding if you have a parent that like happens to work at JPL and they like, oh, just happen to like use the JPL machine shop. So can I ask this, is there an intermediate mission? I feel like the goalpost is there, but the sort of
I think the intermediate mission is an Earth roving thing in some reasonably demanding environment, like the Death Valley or maybe an Arctic region or something like that, like truly rover type environment. as opposed to like, so far nobody has managed to go beyond, I think Mayor's Garden is the most demanding environment so far, which is normal temperature and weather conditions, somewhat uneven garden-like terrain. So I think we should go for one extreme environment.
Or not even extreme. I mean, if more than one of us could exit the polished floor or carpet that we've been on, that would be pretty good.
Yes, extreme.
Extreme like gravel sidewalk.
So
a
not
city is a kind of extreme environment, because we just have docks and stuff moving around and so on, and just sidewalks, okay, or just a bit of snow that we had some funny videos of rows of delivery robots blocked in snow and so on, right?
So
It's
there's
extreme at home.
there's physical extremes or physical environment, but there's also like infrastructure extreme. Like it would be nice to see if we can, I don't know, set up something that works off of the Wi-Fi network or even the cell phone grid. Like, can you go all the way up the stack with like a Starlink base station, setting up local network, or like 2 rovers in the desert with no other communications but mutual ad hoc network that's local radio. So infrastructure extreme, while environmental extremes are still actually, we should start adding rows about that. So basically environment is also a set of options you can target. So how about we make rows for environment for intermediate goals, and we know that the environment for the moonshot goal is Mars, or Mars shot goal is Mars. That's funny.
Yes. At the beginning of the thread, there is a list of already a list of a tentative to scope down not to scope down, to be more accurate about what we're talking about. And in terms of scenario, I think Joshua is what Joshua is asking is about, okay, to do what, okay? And so the idea would be to do something like a simple navigation, okay? And navigation is may not be simple depending on the situation, okay? Because if we think about, for example, Mars, one basic thing will be the locomotion and going from A to B, okay? And if we cast that on Earth, it's already a challenge, especially if we consider some environments like just a city, okay? But to some extent, even a home, okay? Because, for example, there is a problem that most Roombas have, is they can't open doors, for example, okay? So do we want to make a rover that has also a robotic arm mounted on it so that it can open doors? I don't know, okay? But it could be a scenario, a navigation scenario that is not so trivial, thanks to such kind of extension, for example.
Is it a strand beast? Is that kind of the thread? Is it an autonomous organism? I feel like I thought somebody posted beam robotics a while ago. That's a very niche, very, very niche thing. When I was very young, I built little beam robot kits. That was like an 80s thing. I think it was 80s.
I think it was in the 90s.
Was it early 90s?
Yeah, so it's basically a specialized version of behavior-based robots. It's just taken it to the extreme. So it's like insects. So it was after behavior-based robotics. So it was in the 90s.
Yeah, but I mean, like the takeaway from it was an analog computer. So it was like a specifically, I wouldn't say neuromorphic, but it was an analog fuzzy computation system. Like there was no digital circuitry, which was kind of like interesting.
Yes, it's that was maybe part of the high time of cybernetics, basically, right?
Yeah.
So meaning the link to analog computers, in the sense that it was about signal transformation, but through analog circuits. And so it is something interesting because I don't know, there is a lot of appeal in some sense, okay? But I don't know, it feels, I wonder whether we can get it modular, because it's also a kind of different kind of thinking. But the way to conceive and to get that working. Is there recent versions of beam networking? Not networking, beam robotics, sorry.
Not that I'm aware of. There was one guy that kind of pushed the concept for a while, but microcontrollers ate beam robotics, I think. Like you could emulate any analog system that was in the beam robot, kind of like the Zen of beam robotics can now be emulated in software.
Yeah.
I don't know. So for me, because I do deal with this sort of like bomb question a lot. Like this is what people generally pay me to do. Like you can't start from the bomb up necessarily, at least in my opinion. The kind of bottom up approach doesn't allow you to ask the questions that matter. So like the big question here is like, what's the mission, and then how big does it have to be? Because the literal physical size and mass drives all of the everything else, especially concerning the motors, the structure. The power is then determined by the motors and the battery size. The solar requirements determined by the battery size and the motors and the weight. It's a big waterfall chain of things that's all driven by the literal physical size and mass. And that's driven by the mission. And that's driven by the goal. So it's like if you told me you wanted to create a Geiger counter with wheels and roll them over the desert to map the radioactivity over the desert and look for like, I don't know, maybe there's something in the desert that's radioactive. That could be cool. I mean, that could be a cool project, because like a year from now, you could publish a big heat map. And that's kind of like driven by the mission. And then it's like, okay, we have to have a Geiger counter. It's like, okay, well, that weighs this much. Okay. And then it uses this much power. So then the solar panel is this big. So then the frame has to be this, you know, and then right there, that defines your whole robot.
So it sounds like you're suggesting not necessarily a mission, but mission as a way to get at the driving constraint that drives everything else. In this case, the weight and power and requirements of the Geiger counter. So for example, if we decided that the mission was AI-based photography and image recognition, and we picked the OAK-D as the standard choice for that, that would like drive a very different set of constraint box boundaries for other parameters.
Yeah, it very quickly starts to define system boundaries and feasibility. It's a big feasibility, because I think otherwise that you don't consider the notion of feasibility for a particular part unless there's any underlying mission or constraint. That's what I'm saying. So it's like if you wanted the robot to open a door, that's actually a very sneaky one. Just, yeah, I mean, that's very, very sneaky. But if that was what you knew had to happen, yeah, you could always be thinking about, okay, is this actually in support of that objective? Otherwise, if you just want to make the gray goo, yeah, you could just make little blocks. I mean, this is like a very academic, a bunch of labs that do this, try to make the goo.
So I think Rover, especially in wilderness, gives us an easy way to filter some constraints. So for example, I think door opening, even though it's like a challenging and fun little capability, it's not that relevant if the mission you're designing around is, desert radioactivity mapping, right? I think because there's already so much commercial activity around sidewalk robotics and things that can open doors and ride elevators for like the delivery company robotics and stuff, it would be nice to like stick to the spirit of the rover direction and assume a non-sidewalk, non-built environment. So that gives us autonomous power and charging needs, probably slightly more constrained communication, and the weight and overall boundary would be driven by the heaviest sensor we want on the rover. So Geiger counter is an interesting one. Like, how heavy are those things? Never seen
I
one.
mean, you can get little teeny, it depends on the type of radiation you're trying to detect, but you can get little teeny ones that are, like a little clip on for your pocket. Yeah. But it's like, because you mentioned sidewalk robot. So this motor, this is a fully integrated, it doesn't have a motor drive in it, but this is a motor that you'd have on a typical sidewalk delivery robot with encoders and all that. And yeah, this is like $120, and you're gonna need 4 of these, and it weighs a lot. And the solar panel, if you can't recharge from some power source, the solar panel to run these guys would be, it just very quickly, it becomes a big robot and a big budget, like really fast.
So maybe what are the other big bounding box constraints? So we've got the main sensing mission for the rover. I think another one is endurance. So if you wanted to have like a 1-day autonomous endurance, that's a very different problem than a 1-week autonomous endurance. Like there'll probably be like thresholds beyond which, for example, you need recharging capability versus can run on a single charge of a battery before the rover is retrieved, right? So recharging threshold is probably a function of target endurance. So I think the three big parameters is main sensor, endurance, and weight, because weight will determine the sizing of the motor and weight. Am I thinking weight? Actually, it's not weight so much as roving range. So you can have a very heavy rover, but if the endurance you want is just 1 day and you don't care if it moves at like 1 inch an hour and very slowly crawls, you can probably get away with heavily geared down, relatively low power motors, right? But if you want it to go 10 miles in a day, you're talking a heavier, higher power robot.
I think weight is important if we have Mars in mind, though. If we're targeting some sort of CubeSat style program, kilograms to Mars is going to be like, it's going to be very expensive for every extra amount of weight. It increases the expense. So light and cheap and slow are probably our objectives.
Okay, so the other thing,
small.
if it's not going to have a power source, the single driving constraint for almost all of these things is power. I can't underscore that enough. So you will be living, you're going to be living off grid, and it will embody all of those challenges. So like if the robot weighs more, going up a hill, you can only go up a hill that many less feet per day if it weighs more. And there's also like this compounding. The bigger solar panel you have, the more weight it is. But power is going to be a really big deal, because the other parts compute. If you do want to do any compute on the device, that's a lot of power, like a lot of power. Yeah, so like the power is actually a computed value given the duty cycle and the weight and the compute, but that power budget is itself probably the biggest limitation, if that makes sense, to what you can do, because you are not going to be able to run a Raspberry Pi 4 like continuously, is like one example, depending on how big it is.
I added a second tab to the spreadsheet to sort of capture this part of the discussion. Is this a right way to structure it? So we've got like top level bounding variables as rows, and then sort of the short-term mission of Earth roving versus long-term of Mars, and the two kind of have to be aligned. So for example, Rhett's point of Earth roving being a test scenario for Mars roving, the way we would do that is if we like come up with a figure of merit, even though it's an Earth roving mission, if weight is very important for the Mars mission, we would actually add to the weight in the optimization formula for the Earth mission as well. Let's call this mass to avoid them. So for example, if mass is, there's a table of weights. So something like, mass is 5 times more important on Mars than on Earth. We would do something like, use some discounted version of the Mars weight on the Earth mission as well, something like that. So that way the Earth mission becomes a good proxy for the Mars mission. Is this a good approach?
For me, that sounds an interesting approach. I'm just not sure what numbers to put. It's
All right, stop sharing. Sorry.
And the Mars mission is one of doing experiments that are payloads on the platform, or is it just collecting images? Like,
So
what's
there, I think the two should be aligned. If we are doing radioactive mapping in our Earth mission, the Mars mission should be something that's like, the big brother of that. So again, treating the Earth one as a proving mission for the Mars one. I think some things we can take as like take for granted, like, yeah, cameras are basic, certain amount of like image processing is basic, but a rover should have something other than basic. So yeah.
Do you think there is a way to not to simplify the problem, but to scope, let's say, the project by choosing? There are many parameters, obviously, okay, and we are starting to build a spreadsheet. It's like we are starting to discuss maybe some kind of calculator to say we have some requirements. What do we get? What do we need to do in the end? Okay. But what are our chances to succeed in doing that? Okay, so. In a generic case, okay? And so I wonder, should we choose a priority? So for example, Joshua mentioned that power is really the constraint, okay? So should we, for example, choose to have a very standard scenario with a very standard platform that we make ourselves, okay, but very standard, okay? So we don't think too much about the requirement there. However, we have specific requirements on power management. And so if I push the idea is to say, okay, at the center, we put a Raspberry Pi, but we also have a bunch of Arduinos all around. And we have extra logic that the Raspberry Pi will work only for in some when we need it, okay? But most of the time it will be off because it sucks a lot of power. And the low-level functioning of the rover is delegated to just Arduinos, okay, that consume much less and that just have the the reptilian brain part of what is needed for the thing to do whatever it needs to do. Okay? And the Raspberry Pi is turned on automatically because we need it at some point. Okay? So to have some logic. So the goal of the project would be to build that logic. Okay, the power. I'm not sure it's advanced. Okay, but the power management. For given budgets, okay. To scope down the project like that, wouldn't this be something that looks more like challenging and achievable?
Why do you want to scope it down this strongly? Like the way I see the challenge is, if you define the mission parameters, say something like the maximum power budget is so many watts, and that allows for 2 designs. Maybe you use the Raspberry Pi at a certain duty cycle and that sort of fits within the budget, or maybe you use the Raspberry Pi much more heavily, but you fulfill the sensor requirement of, like, say, radioactive measurement by using a lighter sensor. So my thought is, yes, we should have like a couple of like reference build designs, maybe based on like a spider configuration versus a wheel configuration. So we can have reference designs. And I think, like Rhett mentioned, we can have a couple of components that we dictate standardization for. For example, the compute has to be RPi because we're trying to build a lot of common software based on RPi. So some components can be standardized for that type of reason. But otherwise, I don't see the need to dictate architecture at the level of, you must use RPi at like 5% duty cycle, and you must delegate motor control to little Arduinos in each wheel. So rather, I think what we should do is like stay agnostic to the overall design completely, but define the mission requirements very strongly. Like it must have this max power, this average power, have this endurance, and this daily roving range. And it must be able to, like, do radioactivity measurements at this resolution and be able to do telemetry to a base station at this bit rate, right? So you define all these things, and that gives you the bounding box. And inside the bounding box, you remain agnostic completely to the design, except maybe a couple of like things you lock down. Like you must use RPi as the compute, and you must maybe use Llama as the machine learning AI component, something like that. Don't force more than a couple of such components. And then within that space, we can maybe specify a couple of reference builds just to like inspire people to think in a couple of different directions. So here's one spider that satisfies this. Here's a mechano-based wheel robot that satisfies it, something like that.
I'm sorry, I wasn't here for the first 25 minutes, but we're not trying to design a rover which is capable of doing a mission. Joshua has on the shelves behind him pieces of rovers that know how to do missions. I think what we're trying to do is to explore different ways, like this modular idea, all sorts of things we want to explore. And that means to me that the mission should be super minimum in order to give us some, let's call it engineering flexibility to do other weird stuff. The more requirements we put, the more specs we put in, the less likely we are to have a solution space to explore. So I don't care if the duty cycle of the rover is 1 to 70. In other words, 70 hours in the sun and 1 hour moving around. But I want it to be very, very relaxed so that we can explore the space of possible solutions. That is my feeling. So even when we're talking about the effective weight, so I can understand the saying we want the weight to be low or high because we have to fly to Mars, but I don't want to have a lower weight because I want to climb steeper hills. No, flatland. Make it as flat as possible. Do you see what I'm saying?
Wait, Rhett's point about weight specifically was because it's a constraint in space missions because of cost of going to space.
That's fine. That's fine. But when we talk about weight and motor power and let's call it battery charge, as how they interact with how far you can go in a day or what angle you can climb, I'm saying that is more of a problem, because what it's really saying is that we've defined engineering challenges which don't give us the freedom to have a different design. Imagine that I want, you haven't specified a mission yet, but imagine that we want to build a kind of rover that takes 400 hours to learn what it's capable of doing before it starts doing it. Okay? That probably won't fit your spec because it doesn't have enough power to do it and it can't move around and it can't do any mission.
I think the part you missed when we were starting out is we are not trying to define a mission as like constraining box for the project. It's sort of like, at least as I understood what you said, Eric, it's a way to like focus part of the energy, but it's not precluding, like, yeah, if you want to explore modular robotics that sort of loosen or break some of the specs, that's
We-
fine, but just as
we
a
agree.
kind of thing. Yeah,
We agree, but except that what I'm saying is that I want the amount of energy that we're focusing to be as small as possible. That's what I'm saying. I'm saying I want the mission to be really easy so that we have the engineering space to explore other things. I don't want us to get into a discussion, can our robot handle a NVIDIA card, or maybe it's too heavy or we don't have enough power for it.
I think I do want to get into those discussions, and that's why I
Yes,
want a slightly
but-
non-trivial mission to kind of like, again, let's partition the project into two pieces. There's almost the exploratory discovery part where it's like, just learn all the possible kinds of things possible in the largest possible design space. Like the first 3 years, even though we had like a nominal Mars mission, we basically had no mission. It was like, do whatever, right? And now
We
we're
need a
talking for the
mission.
first time, about should we have a mission? And you're suggesting a minimalist mission, like, I don't know, just go from point A to point B might be an example or whatever. But I'm suggesting a slightly non-minimalist mission, partly to kind of like stress our thinking somewhere along a meaningful path to like a realistic, Mars mission. Number one, that's one reason. And the other is, I think it's kind of interesting to have like a subset of our energy devoted to something like, I don't know, non-trivially realistic, like an Earth roving mission. Like I don't know if you missed the part where Joshua was suggesting like radioactive scanning of Death Valley.
No, I
I
heard
like
that.
that. Yeah.
So we already have challenges which we've defined. We want the rover to be modular. We want it to be more of a kit. We want people to be able to fool around with it. These are very difficult engineering challenges. And I think most engineers, given the choice between how do I make sure I have enough power and how do I make sure that it's modular, they're going to put all the energy into how do I make sure it has enough power. And we want to put our energy into how do we make it modular.
I
No,
think
there's
the
easy
design
questions
space
and the
is big
difficult
enough
questions.
So I think we'll figure, if we try, we'll figure it out. But I think the design space, as we are starting to define it right now, is in fact big enough to explore things like, hey, if we have this sort of like budget limited or power budget limited Earth roving mission, can we explore a modular design for this? I think it's like large enough to do that, but I think this is a subjective judgment right now.
I think there's always going to be requirements that we have to purposefully or not purposefully ignore, just because it makes the problem too impossibly hard. And the not purposely ignoring, we just won't even know all of them anyway. Anyone who has worked on an engineering project long enough knows that setting precise requirements is nearly impossible anyway. But like, we're not gonna pick materials that can survive on Mars to build like the first thing, right? Like, we're way too far away from that. So like, I think what Mayor is saying is like, let's be careful about the requirements we choose to not over constrain on things that make it no longer fun, because I think we could easily do. Power budget would be precisely one of those. I think that like, if we needed to last for a month on a single charge or be solar powered, we might be in not having too much fun with what we could do.
Well, that's what I'm saying is if it needs to be mobile power, that is a extremely consequential requirement that you need to go getting into this thing. Like, I just frankly, that's a decision you have to make, period. There's no way around that. And that's not to be like a constraint to, be a burden. It's just like at the end of the day, if you want to put this thing in a box, like that's going to be a real question. We like, my firm's been dealing with like IoT stuff a lot. So this is my little friend here. This is a highly specialized measurement device to measure power consumption. This measures down to like tens of nanoamps. And this is so like you can project, oh, this AA battery will power your sensor for 5 years versus 8 years. Because it really is almost like going to Mars for these little IoT sensors. Like, you're building something that gets the size of a deck of cards that gets bolted on a shipping container for its entire life. And people want it to like just work for 10 years. That's really challenging. And it's really kind of like a remote, desolate land, at least from the perspective of the device over its life, because it has to be completely unattended, autonomous, no help, no support network to it, and it just has to work for that long time. But power is really hard and a really big deal to just it like once you're off the grid, it's real. It gets real really fast, especially if you want it to move. If this is just a sensor that you go tape to the ground, yeah, that's whatever. But the second it has to move, it's a whole nother game.
So let's take what you said and put it to the other end of the scale. You know, when you buy radio-powered, remote controlled cars, you can buy one that works for an hour, and you can also buy one that works only 2 minutes on a charge.
Yes.
If you remember the first levitating skateboards, they only worked for like a minute. Jetpacks, 5 minutes. So what I'm trying to say is, obviously power is an issue, but we should make the minimum requirement of power. Okay, the robot should be able to move 10 meters before it runs out of battery. Okay, so something like that.
Yeah, I understand. Like, I get what you're saying is that there should be a requirement, but it should be minimal to allow the maximal freedom.
Yeah.
So it's like really rein in the requirements for maximum freedom. Completely agree. I'm just saying that power specifically is very binary.
Oh,
so that's totally legit. If you want to go 1 meter per day, that's now a requirement.
Oh, so let me just clarify what I said. I didn't say power was a easy problem to solve. I'm saying that power is an easy problem to deal with. In other words, if you tell an engineer, which problem do you want to work on today? Reducing power requirements or making the device more modular? Reducing power requirements is a meat and potatoes kind of problem.
No,
it's not easy. No. Let me explain. Let me explain. You have a box, right? You have a box that measures power consumption. You don't have a box that measures modularity. You can take your design and tell me, I'm a little bit better than yesterday with regard to power. You can't do that with regard to modularity or with regard to being suitable as a kit for hobbyists. It's a much better defined problem. You have clear goals and you have well-known tools. The things we want to explore are not like that.
Especially with things like sensors, at least for some of the clients that we deal with, like, you have to remember that these devices do actually interact with the world, and the world's unpredictable.
Yep.
So a very, very frequent ask you'll get for a sensor is like, give me a complete list of battery and power projections, assuming that it's in this good cellular reception, and it's only once every day. Okay, well, maybe it's a sensor that like updates more frequently depending on weather events. Turns out that at this latitude on the planet, it's only a third of the power consumption and it's all out of spec. And so the power consumption is not an easy problem to solve, because you would think it was like an easy analysis, but always these sensors interact with the world in some like complex way that's hard to model.
I'm sorry, it's well defined. You know when you make progress. You know that you made a little bit of progress or didn't make it. It's a super difficult problem. When you talk about a battery in 5 years, I mean, it's an impossible problem.
I think you two are talking past each other to some point, to some extent, because yes, there's two dimensions here, well-definedness versus difficulty. But I think the reason we were talking about missions in the first place is missions give you a way to prioritize things systematically. So if it is indeed the case that True North is a Mars mission and Earth roving is like an intermediate mission, then yeah, I mean, power management for a mobile kind of remote rover goes up in importance, and modularity to the extent the mission is modular, like maybe you want to do wide area sensing that requires things to be like, a robot to break into 1 million pieces and spread out, yeah, maybe modularity is important or something like that. But I think the reason I'm liking the mission direction is, one, it gives us like a very sort of charismatic design point to like articulate and present, and like it's easy to understand. If we say in 3 years we want to do a Earth mission in Death Valley, and in 10 years we want to like maybe send a small rover to Mars, very easy to communicate, very easy to like make up speculative like design visualizations and talk about them. Very easy to like I don't know, orbit the shelling points in design space, but that doesn't, I think, stop us from like exploring like, you know, much weirder directions. But I do like the focus that a mission brings, because then you can induce all sorts of constraints from it. And to Josh's point, the little device he showed, I didn't know such a device existed, and B, I would not have learned of its existence if we were not talking about power in the context of like Mars-like missions, right? So in that sense, I think it's good to have like a mission, and we can argue about what the mission should be and whether it should be a mission that sort of emphasizes modularity or one that emphasizes power. But I think we should have a mission. And since we started with Mars, something loosely aligned with that seems like a good idea.
If we have to close the room, just one quick question, sorry. Shall we continue next week? Or is there anything planned for next week? Apparently, we are making progress, but I think we can talk, we can and should talk more.
I don't think there's anything on the calendar for next week. So yeah, we can continue this discussion if it's valuable. I like it. I think for the goal for the year, coming up with like an interesting mission design for Earth, and maybe even like a very rough sketch of a speculative one for Mars, but the better defined one should be an Earth one. That would be an interesting team goal project, including a couple of like specific engineering things, like let's define the compute piece around an RPi for the Earth mission, something like that. So yeah.
I will say I will put myself on the accountability loop to close the presentation that I didn't finish about Isaac 2 weeks from now. Now that I have a GPU and I've gotten some seat time in Isaac a little bit. So yeah, I could volunteer for that. I will also, just to kind of vaccinate and food for thought, that design of robot is what I would suggest just to consider, because it is the simplest thing you can build. It's the cheapest, simplest thing. It has 2 motors because there's 2 degrees of freedom on a Cartesian plane. It's literally 1 box and it has a tail. That's it. Print it out of something that can deal with the Mojave sun and you're done. That's it. That's the whole robot. Cheap. All right.
Yes.
Going to stop recording, and I'll have to log off to start my other